All right, so these are examples of trying to solve systems of equations, and these two problems are both in the format of y equals mx plus b. I'll write it down here. We have y equals mx plus b. And so I'll start with this equation right here. For this one, we have my m is going to be right here. M is going to be 5/2, and my b is going to be equal to 3. So if I wanted to graph that, I begin with 3. It crosses the y-intercept at 3. And then I move 5 over 2. The problem is if I rise 5, 1, 2, 3, 4, 5, I'm off the graph. So instead, I'm going to say that my m is, instead of positive 5 over positive 2, I'm going to call it negative 5 over negative 2. A negative over a negative is a positive, so it's the same thing. But now it allows me to find my second point, because from this point, I can go up negative 5, which is the same thing as going down 5. So 1, 2, 3, 4, 5. And then to the right, negative 2, which is the same thing as going to the left 2. 1, 2, to right here. Right? If I'd started with this point, then I would just go up 5 and over 2. So that's my slope, is 5/2, even if I go down 5 and over 2. So now I've got these 2 points. So I can graph the line. It looks something like this. It goes from here to here like that. Or from here to here like that. Okay, so there's my line for the first equation. The second equation, I'll put it in blue. And for this one, we have the m is going to be, in this case, negative 1/2. And my b is going to be negative 3. So I come down to negative 3 right here. I'm going to begin right there. And then I'm going to rise negative 1, my rise overrun negative 1/2. So I'm going to, in this case, I'm going to rise negative 1 and run 1, 2 to right here. And so that then lets me draw my graph from here to here. Whoops, sorry. Let me make it a line. Okay, so from here to here like this. And from here to here like this. Okay, and now you can see there's one point that works for both the red line and the black line. I'm sorry, the red line and the blue line. And that point is right here. And that point is x is negative 2, y is negative 2. So the solution is going to be negative 2, negative 2. That's the only solution that's going to work for both the red point and the white point. I'm sorry, the red point and the blue point. All right, let's try problem number 2. Same thing here. We've got, in this case, we're going to have our m equals negative 1/2. And my b is going to be equal to negative 4. So I come down, I begin at negative 4, and I rise negative 1 and run 2, 1, 2. So there's my second point. And so then I'm going to make this into a line and graph this line. It looks like this. 2, 2 like that. Okay, there's my red line. And then the blue one, looking over here, my m is going to be equal to 5/4, and my b is going to be equal to 3. So I begin at 3, and once again, if I try to go up 5, 1, 2, 3, I'm going to be off, so I'm going to say my m is going to be equal to negative 5 over negative 4. It's the same thing, a negative over a negative is a positive, except now it allows me to draw my second point on the graph. So I go down 1, 2, 3, 4, 5, and over to the left 4, 1, 2, 3, 4 to right here. And then if I draw that graph, it's going to look like this. Okay, and where's the point that they cross? They're going to cross at this point right here, which is -4, comma, -2. So the only solution that's going to work for both this blue line and this red line, I'm sorry, I drew the red line not exactly perfectly. I can do a better job of drawing the red line here. Sorry, let me do that. If I draw the red line should actually come up like that is a better one. So you can see it crosses at -4, -2. That's the spot that's going to work. That's the one point that works for both the red line and the blue line. So there's the solution to my systems of equations. All right, so for number 3, it's very similar to 1 and 2, except the problem is it's not automatically in a form that we can easily graph. This is in standard form. And so there are two different ways I can graph standard form. Let's do the way that always works very easily is I can just always turn it into y equals mx plus b. So let's write our first equation over here. We've got 2x minus 5y equals 20. If I want to get that into y equals mx plus b, well, I want my y's on one side and my x's on the other. So if I subtract 2x from both sides, now I have -5y equals -2x plus 20. Now I just have to isolate my y. I don't want -5y, I want just y. So if I divide this by -5, but of course if I do that to this term, I've got to do it to this term and this term as well. So the -5's cancel. So I have y equals, a negative over a negative is a positive, 2/5 x. And positive over a negative is a negative, and 20 over 5 is 4. So I've got y equals 2/5 x minus 4 for my first equation. For my second equation, which is 13x minus 5y equals -35. Once again, I'm just going to do the same thing. I want my y's on one side, my x's on the other. So if I subtract 13x from my left, I have to obviously do it on my right for balance. Those cancel. So I have -5y equals -13x minus 35. And now I want to divide by -5 because I want to isolate my y. So I'm going to do that to all my terms. And when I do that, those -5's cancel, so I'm left with y, and that's going to equal a negative over a negative is a positive, 13/5 x. A negative over a negative is a positive, and 35 over 5 is 7. So now I'm ready to graph these. This one, my m is going to be 2/5, and my b is going to be equal to -4. So I begin at -4 right here, and I go up to 1, 2, and over 5, 1, 2, 3, 4, 5 to right here. And I can do it again if I wanted to, up to and over 5 to right here. And then I can draw that line. It's going to look like this, going down to and over 5, so it looks like this. All right, for the blue one, I know that my m, in this case, is going to be equal to 13/5, and my b is going to be equal to 7. So I just go up to 7 where I begin, and from here, I'm going to go up 13. Whoops, I'm off the graph, so I'm going to instead say that m is equal to -13 over -5, so I can keep it on the graph. So from here, I go down 13, so I'm at 7, so that's 7, and 6 more would be 13, and then over 5, 1, 2, 3, 4, 5, right there. And if I draw that line, it's going to look like this, from here down to there, or from here up to here, like that. Okay, and so then the point where they actually intersect is right here. That's the point that works for both of them, and that looks like point number -5 and negative 6. All right, problem number 4 is very similar to the last one. We have two different equations in standard form. Let's put them into slope-intercept form so it's easier to graph. We've got 7x plus 2y equals 12. So for that one, if I want to isolate my y, if I subtract 7x from both sides, that cancels, so I'm left with just 2y on the left side and negative 7x plus 12 on the right side. And now I don't want 2y, I want just y, so if I divide by 2, those are going to cancel, but if I do that to this term, I have to do it to that term as well, and this one. So on the left side, I'm just going to have the y, because the 2's cancel, and on the right side, a negative over a positive is a negative, negative 7 halves x, and a positive over a positive is a positive, 12 over 2 is 6. So I know that my slope is going to be m is going to be negative 7 halves, and my b is going to be equal to 6. So I begin with my 6, I go to my y-intercept and go to 6 from right here, and then from here I'm going to go down 7 and over 2. So down 7 and over 2 gives me this point right here, and if I want to do it one more time, down 7 and over 2 is right here. Okay, now I can draw that line easily. It looks like this from here up through there like that, and from here down through there like that. Okay, so there's my line. Now I can do the same thing for the other equation, which I'll do in blue. So we've got the other equation is 3x minus 2y equals 8. I want to isolate my y, so I'm going to subtract 3x from both sides. Those cancel. And I'm left with negative 2y equals negative 3x plus 8. So if I divide by negative 2 to isolate my y, and of course I'm going to do that to all my different terms, those cancel, so I'm left with y equals a negative over a negative is a positive, 3 halves x. A positive over a negative is a negative, and 8 over 2 is 4. So now I have that my m equals 3 halves, and my b equals negative 4. So I'm going to graph it by beginning at negative 4 right here. And then from here, I'm going to go up 3, 1, 2, 3, and over 2, 1, 2, to right here. And then I'm going to do it again, up 3, 1, 2, 3, and over 2, 1, 2, to right here. And so now I can graph it. It's going to look like this. Okay, and comes down and looks like this too. Okay, and now I know to find, well, where does it intersect? Where's the point where it intersects? And it intersects right here, which looks to be at, what is that, 1, 2? This looks like it is 1, 2, 3. I can't even see it. 1, 2, yeah, this is 2. Okay, no, sorry, this is 2, negative 1. 2, negative 1 is where it's going to intersect. And so that will be the solution to both the red line and the blue line. All right, so looking at number 5, we've got two different equations. We've got 6x minus 5y equals 45. So if I want to put that into y equals mx plus b form, if I subtract 6x from both sides, that cancels, so I'm left with negative 5y equals negative 6x plus 45. And then if I divide by negative 5y across each of my terms, I'm going to end up with y equals a negative over a negative is a positive 6/5 x. A positive over a negative is a negative. 45 over 5 is 9. And then if I do the same thing for my blue equation, that's going to be 6x minus 5y equals negative 20. Subtract 6x from both sides. That cancels. I'm left with negative 5y equals negative 6x minus 20. If I divide each term by negative 5, I end up with y equals a negative over a negative is a positive 6/5 x, a negative over a negative is a positive plus 4. So if I draw those lines, the first one, I have my m of negative 9, so it's down here at negative 9, and then its rise over run is 6/5, so I go up 6, 1, 2, 3, 4, 5, 6, and over 5 to here. And so my red line looks like this. And then my blue line, I begin at, it says right here, I begin at 4. So I come up to 4. And my slope is 6/5. So if I go up 6 and over 5, it's to right there. And so this one looks like this. If I draw the line, it looks like that. And so hopefully you can see that these are parallel lines. They're parallel lines because, as you can see, the slopes are equal. And we learned earlier that if you have this equal slopes, the slope of the red one is 6/5, the slope of the blue one is 6/5. They just have different points that they cross the y-intercept. So these are parallel lines. So where do they intersect? They never intersect. That's what parallel lines means. So the answer is there is no solution. There is no solution to this. There is no point that's going to work for both the red line and the blue line because they never cross. So there is no solution. That's a great. All right, let's take a look at problem number 6, which has for us negative 6, and I'll do it down here. We have negative 6x minus 9 equals negative y. If I want to make this into y equals mx plus b, if I multiply this entire thing by negative 1, I'm going to have 6x plus 9 equals y. And if I just flip it around, take the y and put it over here, and the other button put it over here, I'm going to have y equals 6x plus 9. Okay? And so I could put this on, I know the point's going to be right here at 9. And then I'm going to go, I go up 6 and over 1. Nope, I can't go up 6. I'm going to go down 6. So I'm going to go down 6 to here and over 1 here. So it's going to look like, oops, sorry, over 1 to here, sorry, 6 to 1 right there. And so the graph is going to look like this. Okay, and then the blue one is, oops, sorry, the blue one, let me do that. Okay, the blue one is y minus 6x minus 9 equals 0. If I add 6x to both sides, I get y minus 9 equals 6x. If I add 9 to both sides, I get y equals 6x plus 9. And so once again, I would go to 9, and I would go to I'd go down 6 and over 1 right here. And you can see right here that these are the same 2 points. And of course they are. this equation right here, when I put it into y equals mx plus b, is the same as this one right here. So if I were to graph this blue line, it would be the exact same line as the red one. It would be right on top of it. It would look like that. So the answer to this one is, what's the solution? The answer is there's actually an infinite number of solutions. And what those infinite number of solutions are they're all the points on this line going down and down forever and going up and up forever. Right? There's an infinite number of solutions. All the points on this line, since the red line and the blue line are the same thing, then all the points on the line solve both equations.